Well, hello everyone. Today I decided to try something new. I will try to code a simple production style C++ app. Now in this case it will not be a cross-platform C++ type application because we will be dealing with Windows and Win32 in particular. Now I at first didn't want to do this kind of like this way, but what came up is that I needed to remove a digital signature from a file. Now what am I talking about? Well, if I look, let's say, at my own file, at my own binary, let's say this one, if you look at it, you know, an executable in Windows in this case might have digital signatures, and this basically, you know, signs the file. In this case it's my signature, so it kind of like gives authenticity. But I was looking at ways to patch binary files, and when you patch them, when you apply binary patch, the signature will be broken. So in that case, if I did that and went into digital signature and went into details over here, it would not show me that the signature is okay. Now that was bad because, you know, this could cause all kinds of problems. First of all, it's probably not nice to have a broken signature on the file, plus it can actually cause problems with antivirus software. So that was my purpose, you know, to find some software, some tool to remove digital signature from a binary PE file. Now, to my amazement, I couldn't find such software, so that's why I decided to write my own. So just as a test, we will be using my own file here. So I created a copy, and again, as you can see, it also has a signature. I just made a copy. And so we will try to code it. So I will do the coding process from start to finish, and I will create a production style application so that you can see how I would do that. Now real quick, just to kind of like give you an overview of what I'm trying to do here. Let me see if I can draw it with the mouse. So if we take a binary file, right, so I'm just gonna do like very simple overview. So this is a file, so right, this is the offset 0, and this is like the end of it. So a PE file, it's not pretty easy to write it with the mouse, but pardon my horrible graphics here. So the PE file is a certain structure of a binary executable file, in this case in Windows. It's probably used in other platforms, but right now I will be talking Windows only. So pretty much any exe or any DLL or .sys file is a PE file. Now if you want to know any specifics, and you probably do need to know this, PE file format. So you can Google, and pretty much the first hit from MSDN, from Microsoft, gives you this really huge document that you can review and see what that is. Now in a nutshell, PE file is broken down into several things. Now first of all, on the top is the header, which is called PE header. It's always in the beginning, and it's basically a bunch of adjacent structures which are explained over here, you know, in all the details. So like all these things, file headers. And then what follows are sections. So you have section here, you have section here, you know, they're all different size and they're kind of like arbitrary. So right, so you have section, 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 and section. Now how these sections are laid out and their size are, you know, all these things are defined by the compiler. So well, compiler is something that builds this PE file, and compiler usually is the one that does this. Now the thing that one needs to understand is that these sections, the way PE file are treated, it can be kind of like in two forms. One, it can be in a file form. So right, so when we're talking about a file on disk. And then it can be also mapped. Now, what is mapped? Now, mapped is when you actually load this file into virtual memory. Now, the main difference is that, let's see if I can, there's no way I can recreate the same thing. But the main difference is that when the file is mapped into memory, let's say I'm trying to match, sizes of sections, there can be gaps between these sections, right? So let's say that there's this gap, and then there is like this gap, and then the last one has probably like a smaller gap. But basically what I'm trying to show is the correlation. So this section is this one is this one is that, and that one is that. No, sorry, obviously it should be larger. But these gaps here, between sections, is the way this file is mapped in memory. Now, why are there gaps? Well, the gaps exist because, this is the way each section is allocated in pages in memory. So just to save space, I guess, in file, these sections are all bunched together. So, there's no spacing here. So this is the main difference. This is kind of like the main point of confusion about PE files, when they're mapped and when they're in the file form. Now, in our case, to remove the signature, we need to understand where that signature is located. So in our case, when the file is actually, when the PE file is in the file form, there is a kind of like last part of the file, which we would call resources. And the resources section has, one of them can be digital signature, right? So I'm going to put this kind of like a padlock type thing. Now, the digital signature is what defines our signature. So in other words, when we go here in the properties, now this stuff, all the information, all the details about the signature itself is stored here in this last section. Okay, so by removing the signature, what we need to do, we need to remove this part, which will assume that is always at the end of the file. That's what my testing showed. And it seems like this is what's going on when actually the file is signed. And also we need to adjust the header a little bit to tell the PE parser or any PE processing software that there is no digital signature at the end. So this is what we will be doing. So it's kind of like a quick overview. In this case, you don't really need to understand the mapping part, like all the gaps here, but because we will be just dealing with the file. Okay, so just to begin, I guess let's fire up Visual Studio 2019. I'm going to create new project. Now I will be working with the console app because that's the most appropriate thing to do here, since we're not really working with GUI. Now, if you need to find it, you can just do console and pick C++ console application. Just for the lack of better name, I guess I'm going to call it SigRemover. I wanted to call it SigRem, but there's something like with that name that already exists. So I'm going to call SigRemover, and let's create it. So basically it will create a template for us that we will need to adjust. First of all, we don't need any of this stuff. And now before we can go ahead and start coding, I'm not a big proponent of putting everything into one kind of like file, because it's just not as readable. I usually separate stuff, especially even for smaller projects, into different header files or different classes. Now, in this case, I will create a special H file, which is called types. And in this case, this will be custom. Oops, typing is not my thing here. is custom types. So pretty much all the custom declarations, all the custom definitions will go here. And let's see, I also want to create a class. Now most of my code will go into this class, and again, for the lack of better name, I'm just gonna call it SigRem. And the reason I'm doing SigRem is because it's just faster for me to type, because this class name will be used, you know, in a lot of places. So let me do some basic formatting. So I'm kind of proponent of using comments in classes so that you can kind of tell what things are. So I would just call SigRemover main functionality. So, okay. And I would probably take that and also move it here in the actual class. Okay, and then when we go to the to our main file, we just need to include our header here. Now in the header, we will need to add a few things that we will need for our Win32. Now first, I'm going to add char for the for working with character strings and using all the character APIs that provided by CRT. Obviously, we will need windows.h. Now this one is mostly Win API stuff. I will also need string safe. This is for strings, for safe string APIs, the new ones. I really like them. We will need asserts. These are just for debugging assertions. And lastly, let's just include our types here. Okay, so this is kind of like the basic scaffolding here. Now the thing that I wanted to change right away is to change this main into a different version, which is tmain, that takes argc and gives us argv as parameters. Okay. Now also we will need an exit code, and this exit code will be basically returned from our application. Okay. Now in this case we will be building only 32-bit version, because again obviously there is no need to complicate things and build two versions, because you know really just 32 is all we need. And let's see if this thing builds. Okay, well there is one little problem that we need to check. It's just the spectrum mitigated libraries. Now we don't care about that in this case. So let's see if I can disable this. So we will disable it here. Let's see if it builds. And I'm looking at the bottom, and it does. So when we run it, it returns 0, like what we wanted. Also, let's do release build, and also if we go into properties for the project, and if we do Spectre, the reason I disable it is because, you know, this solution is not really a security risk, because it doesn't really do anything. You know, it just simply runs one task, and it cannot cause any Spectre related issues. Okay, so release build is also working. So let's go back to debugger, and let's start populating our project. Now, first of all, what we will need in our types, well, let's just do some basic debugging thing. Now, what I like doing is defining a few things which are debugger specific. Now, one thing that I really like is having a verify assertion. Now, what happens let me just show real quick. And if we do else here, and I'm going to copy and paste. Now I'll be copying and pasting a lot of my code here because, you know, any programmer doesn't like typing. Okay, so what I've done here, I defined a verify function. Now, just to show you real quick, there is assertion. So if I make, well, like this, assertion equals 0. So in this case, this assertion will pass. Now what this means is that when we create a debugger build here, it's kind of like for us to check variables if all the like parameters and stuff are correct. So when I run it, this will pass. Now if I put it like this will cause an assertion. You see, so then I can retry and I can actually see where the problem is. Now assertion are included only in debug builds. So if I do release, this assertion obviously will not fire, so it will be ignored. This string will just not work. Now if I want to do this if let's say if I had some kind of function call here which I wanted to keep, in this case I would use verify, because, you know, in release it will actually keep that function. So that's kind of like my little thing that I'm adding. And let's see, we should probably define these return codes as like certain as an enum. Now let me go here and let's call it exit codes. Now this is your own way obviously to do things, guys. So in my case I like to define all my definitions and enums in all caps, but again it's up to you. So let's see, exit code. For now, let's just do success, which would be 0. And let's do xc gen failure, which would be -1. So we'll add them later, but right now we just have these kind of like basic enums. And let's see, at this point, let's just assume in the beginning that we have failed, okay, without doing anything. So let's make sure it compiles. Okay, and it does. And again, what we're doing here is just basic scaffolding, so even before we can even start coding anything. Now what I usually like to do on the top, I would do a couple definitions, and I would do app name, and another definition, app version. Now we don't need it right away, but it will come handy later on, and I will call it binary file digital signature remover app, and the version is 1.00. I go with just, you know, 3 digits here because of the MSI, you know, limitations. It doesn't take the 4th digit. So that's why I just stick with 3. Now the reason I put these into kind of like a shared types file or some kind of definition file and just reuse the preprocessor instead of just typing it everywhere, well, it's just for that. So in case I change something, I just want to change it in one area, especially with the version. Okay. Now we don't need this right away, but we might add it later. What I always like to do, let's see, I like to add, let's see, resource view, and I would like to add a version, new resource, and version. Now what is version? Well, version is when you click properties on the actual binary and go into details, it would give you all this information. Now the reason I like doing this, it kind of like, well, I would say introduces, kind of like gives you, whoever wants to know, gives information about the author and about the app itself. Make sure to change the version to make sure it matches. So now the company name is important. This is basically to tell people, or, you know, any antivirus product that, okay, here's me. That's, you know, who wrote this thing. I would also like to copy this into file description, and also the same thing into the product name. You know, it's a simple application, so we're not going to be complicating things. Now this one is remover, so let's put a copyright again, just kind of like, you know, in a production code, you would put something like this: all rights reserved. And again, internal file name, let's just use the full thing. And here it is. It just, again, just to tell outside entities who wrote the file and what the file is about. This is kind of like, you know, removing anonymity and kind of like introduces things. Okay, so I'm going to close this. And let's see what else can we do. Well, at this point, we can probably go into our actual class. Let's see, class view. And it doesn't have anything, so we need to start from well, let's see, what can we start from? Well, we start from declaring public methods or functions. Now at this point, well, we need to remove digital signature, so that obviously has to be a function. I would think that return value would be one of our exit codes, which we'll just pass back to the main. And let's just call it remove digital signature. Oops, if I can spell. I apologize, I'll probably misspell a bunch of things. Okay, so remove digital signature, and it's taking a parameter, which would be string file path. Okay, so this is just that kind of simple type declaration. So let's do definition, and let's go to it. Oops, I guess it doesn't want to do it this way. Okay, we'll do it this way. Okay, so let's give us some space, and so I don't like defining it like this, so let's just call it end result, and we return end result. Now, we probably need another instead of general failure. Usually I return general failure if it's just kind of like in the very beginning, kind of like a fallback type failure. But in this case, let's create another more specific error, which is called failed to open, and that would be -2. Now, failed to open would be specific for our function here, which is opening digital signature from a file. Now, what I usually do on the top, I write what this function is about. It opens the file and removes digital signature from it. Okay. Okay. Well, as I said, I will be using Win APIs. So let's just open our file for reading. Now, since I'm using Win APIs, I will be using a function called create file. Now, I know it's kind of weird that they call it create file, but technically it's also opening file. Now, you can look it up on MSDN. I'm not going to go into specifics, but you can learn how it works here. So what's important for us here is that when it returns, it gives us a file handle, and we call the function. Now, the reason I'm using double colons here is because it's just faster for me to invoke IntelliSense. So you see, when I do this, I can just do create f and create file. So it's just from being lazy, that's why I'm kind of doing that thing. Okay, so first parameter is a file path. You can actually see IntelliSense. Now, desired access is generic read. We don't need any other access. Now, the sharing mode is file share read, and also file share write. We're just going to go with that. Now there is no security attributes. We do open existing because it has to exist, and file attribute normal, I think. In this case it doesn't really matter since we're opening file. And here you go. Now we're not using any template. Okay, in this case we need to make sure that the file has been opened. And the interesting thing is that this function doesn't return 0 in case of an error. It actually returns a predefined value. It's -1, but basically it's invalid handle value. So make sure to check for that. And also, which is very important, you have to always remember to close your handle. Okay, so we're doing close handle h file, and in this case I will use my verify to check that this function actually succeeded. Now why do I do this? Again, this is just for kind of like sanity check and for safety, I guess, to make sure that I didn't mess something up and this API actually succeeded. Now the reason I use verify instead of assert, again, is because assertion will remove anything that's inside when I do release build. This is important because it's a cause of many bugs actually. So in this case it has to be verify. Again, if we look at what it is in release build, it will just keep whatever is inside. Okay, well, this is for opening a file. Let's make sure that it actually works. Doesn't really do anything, just opens and closes it. Okay, well guys, since I told you that this is a production application, we have to handle errors, and this is very important. So we have to do else, and we say here that this is an error and we need to handle it. So I personally don't like to handle it just here. I prefer to actually create a special method. And for that, we need to do it, well, about right next to it. So let's just say that this will be void, and just let's call it report OS error. We'll do the declaration in a little bit. So it would take OS error code, and let's provide some kind of a variadic function to provide a little string, a formatted string, and it will be variadic. So in other words, we can add parameters. Okay, so if we let's see, if we copy, now unfortunately I don't think it would let me add it automatically. They broke something. If I do declaration, oh, it did. Okay, so it actually worked. Oops. So it's a static method. This way we just added it to our header. I'm sorry, into our declaration file header instead of typing it. Okay, so in this case we will be reporting errors here. Okay, now what do we do? Well, the thing that we need to do, since we have this error code, we need to convert it into a readable message. Now we can do this with the API, which let's see, I believe is called format message. And we need to probably specify, yeah, I actually did find it. Format message, it's when base, MSDN. So this function, what it does, it converts, it's kind of like large, but it converts OS error code into actual readable message. So you know what, instead of writing it in here, how about we create our own function? Now the problem for us here is that it creates a we need string of a variable size. So That is why we will have to probably do it in a separate implementation, just to kind of like simplify things a little bit, just coding wise. So we'll call it get formatted error message, and again it takes OS error code, but in this case it takes our predefined buffer. Now, which is very important to prevent buffer overflows, is to provide the actual size of the buffer. So we will provide it in chars here. In this case, we need to explain what each parameter is. So this one is obviously OS error code. Buffer is, let's say, buffer to fill in with error description. So it has to be pre-allocated by the caller. And size is actually size of buffer in chars. Oops, not chats, but chars. Now this is very important, that this size is not in bytes, but in chars. Okay, and then we return, let's see, pointer to, and it is always null terminated. Now this is very important. We will make sure that it's always null terminated, so that, you know, any string functions would rely on it. Okay, so now let's just add declaration. It's also static, and what we need to do, we need to define these as protected, because they shouldn't be, you know what, no, actually this one might be used from outside, but this one is protected, so it's kind of like internal function. And at this point, let's see what we can do. Now first, we need to preserve our error code, because, you know, we'll be changing it internally, and we need to kind of like reset it at the end. Now what happens is that this last error is changed internally. So whatever we're doing here, we should not be messing with it, because, you know, since we're reporting, we need to preserve our last error. So that's what we do here. And as our return says, that we will return the same buffer. It's just for simplicity, so that we can use this in line with, like, in function calls. Okay. Now at this point, we need to make sure that our size is not 0, because if it is, this is a bug in our logic. We cannot pass 0 here. So this assertion will basically tell us, like, hey, there's a problem. You can't pass buffer of size 0. Okay? And we need to see if we actually have an error code. If we don't, well, just basically means no errors. No errors. And what we're doing in this case, we're just zeroing out our string. Just doesn't output anything, because, you know, outputting no errors when we need an error, or saying, you know, like successful completion, is not good when we need an error. It just would look funny for the caller. Okay, so then we need to call the actual API. So this one is kind of like, you have to read documentation what it does, but basically we need it to, let's see, format message allocate buffer. We need it to allocate the buffer for us. We also need it to give us result from the system, and we also needed to ignore, let's see, ignore inserts as just special inserts that we don't need. Now we're not interested in the source. Now next we provide our actual error, and language ID, we will be using language, well, let's just do neutral, and sub language, let's see, Sublime default. We're just not really interested in providing any specific language here. Now this parameter is the actual buffer. We'll fill it in later. We're not interested in size, well, because it will allocate it for us. And last parameter, no arguments. Okay, so then we need to provide a buffer, and we also, actually no, we don't need that, so we need to pass it here, but it won't like it. We need to pass it a pointer to it, and here it has to be special type. Okay, and okay, now as a safety mechanism, let's clear out our string first, that we passed in case our API fails for whatever reason. Okay, and now if we have an actual result, because again what we've got here is that we, this function, when it returns, it will allocate our buffer here and it will populate our pointer here. So if we got something, we can actually use our string function, not our, but one of the safe string copy functions, to populate our buffer. So it takes it as a source. Now the size is the size of the buffer that we asked for, and the source, I'm sorry, the destination is the buffer that we got. That's the size, and the source is our string that we've got here. Okay, well, just for kind of a verification, we can make sure that this has succeeded. It's just a debugger check, just to make sure that we actually copied everything that we've got. And last thing, which is very important, is to free this string that was passed by the API for us back. Okay, so last thing that I like to do is just to kind of do like a, I call it safety null. What this means is that I always null out the last character of the buffer. Now this is again just a safety check to make sure that the function, the API, the Windows API, actually did what it's supposed to do. Again, that's probably an overkill, but it's very simple to do, and it's just like kind of like my way of preventing all kinds of buffer overruns and buffer overflows. And one other thing that we also need to do, we need to remove all special characters, special chars from our string that we have here. Now this function likes to add new lines into result, but because we will be outputting it into one line, we need to remove that. So we will just quickly go through our string, I'm sorry, through our buffer. So we're going to do it in the for loop. And let's say we'll read a char from it, and if it's the end of the buffer, we will break. Otherwise, we need to see if it is this or if it is that. Basically, two versions of a new line, and if so, it will simply replace it with the space. So it's that simple. So it's just a little kind of like a cleanup for us, just to make sure that everything stays on one line. Okay, so this function will fill in our buffer that we pass in with, with the error message for the error code that we provided. So now if we go back to our report errors, we can actually use it. So we can say format error message. Now in this case, we can safely create a error buffer on the stack. Let's just do 1024, kind of like thinking for like a larger buffer. Again, a little bit of a safety check. Let's just initialize it, just put initial 0. And then we can call our get for, let's see, how did I call it? Formatted. Here we go, formatted error message. So we pass our OS error code, we pass our buffer, and we pass the size of that buffer. I personally like to use count of instead of just hard coding it here, because if you change it to some different size, you don't have to change it anywhere else. So that's why count of is really helpful. So okay, so now this will populate our buffer, kind of local buffer with error message, which is kind of nice for us. Okay, well then we need to see, do we actually have the user message? So do we have a user message? And so the way we can check is by just doing this and to make sure that user actually didn't pass an empty string. And in this case, yes, we have a user message, and here is just no user message. Okay, so let's just do the kind of like easy situation when there is no user message. So in this case, we just do wprintf. Now this is like my fast way of outputting something into a console window. So then we'll just do error. Now here we will output the actual error number here, and then we will output error description and a new line. Okay, now error description is this here, which we already processed, but now we need to see how do we output error. Now, in most cases, just an int would be fine, but sometimes Windows reports so-called H results or status codes from the kernel. In that case, this value will have to be formatted as hex. So let's take care of that. So pick the right format for the error code. So we need another buffer. Let's see, char. Let's just call it buffer error code. It doesn't have to be anything big because it's just an error code. And again, as a safety, let's put initial 0. And then let's see. So we have two options. Now we need to treat it as unsigned int. And let's see if we have if you have two high bits set, any of them, then we will treat it as a hex. Otherwise, we will treat it as unsigned int. Actually, you know what? Let's just treat unsigned int. That's the correct way. Okay, so in this case, the unsigned int is the easiest way. We will use again one of the save string printf functions, and we will printf into our small buffer here. Make sure to provide its size, and we will use just simple unsigned value here, which is %, and our error code. And again, just to make sure that we got, we didn't fail here for some reason, we need to verify, put assertion, but again, it has to be verified because we need to keep it in the release build. And for the hex, kind of do similar thing, except we do it like so. Okay, so now we can use this buffer to output our error code. Okay. Well, I'm thinking we also need to restore last error here before returning. It's just kind of like, again, a kind of important thing so that we don't destroy the last error with all the API calls that we do here. It's just, again, just kind of like a little safety thing. Okay, and the last thing is to handle when we have a message with the variadic parameters. Well, in this case, we need VA list with arglist. Again, this one is just like a standard way to process variadic parameters. and we do start, and we have arg list, and then we pass this thing here. And at the bottom, at the end, we have to do va end and put our arg list. Okay, now then we will use a function to get length of our variadic string. We call it nln buff. Fortunately, it works with ints, and it's vscw printf. Kind of like very strange name. It's one of those built-in CRT functions. So we pass this, and then we pass argument list. So it will return us the number of characters that we need. Then we need to reserve a buffer. So we do wchar buffer. Now we will use, in this case, we can't use stack. We will use heap. Now keep in mind that we need to reserve this +1 for the null. Let's make sure that we succeeded. In this case, if we failed, we can't really print an error. We just assert in case of debugger build. And we always have to remember to free memory. I always do it first before coding anything, while kind of like I remember what's going on here, so that I always have this delete at the end. Okay, and let's see, then we have to do actual formatting. And the formatting is vsw printf s. It's a save function. So what it needs is a buffer. Then it needs the length of it, and +1 for the null. Then it needs the format string, and it needs the argument list. So that's what it does. Now again, as I always do, I'm putting a safety null at the end of this buffer that we allocated, because even if this API doesn't work or fails in some way, I should be able to create a fully null terminated string here. Okay, so, and then when we did that, all we need to do is just output it into the console. In this case, what we are going to do, at first we will output our message that we just formatted. Then we put a new line and just say error, and kind of like what we did, you know, earlier, right? So we can pretty much take it from here and just format it like this, and we output it to the console. Okay, and that's technically all we need to do in this report error message. Just to make sure it works, let's just do quick demonstration. So let's say error, let's say 5, and error 2, and value is, and do it this way. So if we run it, that should technically use, okay, well, we have a problem. Let's take a look at what we're doing here. Oh, obviously, this has to be equals, just a typo. And function does not take one parameter. Okay, so what we forgot to do, we forgot to define that we do not have to provide a string here, kind of like provide default parameters. In this case, it would just simply take nothing. And in this case, it will actually take get last error. Right, so we don't have to really specify anything. You can just call it empty, like So if we just say set last error, let's say 1, 2, 3, it will use whatever last error is to output it. Well, let's see if we can get it to work. Okay, I'm not going to run. Well, actually, you know what? Let me remove all the breakpoints, which I already removed, and let's run it. And it ran fine. Return -1 like we wanted. And let's try without debugger. As you can see, error 1, 2, 3. The first call here didn't output anything. Then error 5, access denied. That's the second one. And the third one is our value -1, and it outputted error 2. The system cannot find the file specified. So what it did, it basically converted all of these values, numeric values, into the actual description for the person. Now the good thing is that these descriptions are localized for the operating system, so it will be easy for the user to actually see what the error is. Okay, so this was our scaffolding. So now technically we can go ahead and continue with our main method. So the main method, if we look here, this is actually working with the file. Okay, now guys, I'm seeing that this video is getting kind of long at this point, so I will break it into two chapters, I think. So just to kind of make it more digestible. So at this point I will pause it, and again in the next section please come back to see how we will write the actual removal of the digital signature. So thank you for watching, and see you next time.